Hello, everyone. My name is Sean Kendall. I'm a data scientist at Galvanize, and my project is on Amazon stock prediction. A quick roadmap of my presentation. First, we'll talk about the model I used, then the feature selection, then the results. Then I'll have a quick flash demonstration, and I'll talk about future steps I want to take. For my model, I'm using a recurrent neural network, and this is using 5 LSTM layers that are bidirectional. That takes historical and future data and relates that to the current performance. And between those layers, I'm using a dropout layer, which helps with normalizing the data. And finally, a dense layer at the end to get our output. My goal for this project is to predict future Amazon stock price. In my previous project, my results essentially predicted that the future price would be the same as the current price of the stock. And this had high variance or overfitting in the predictions. So for this project, I want to add more generalization to the predictions. And by doing that, I want to smooth and diversify the features. So I began by using the 5-day average for stock price, and this smooths out the jaggedness of the stock. And then I want to diversify with the stocks related to Amazon. And in particular, I want to use Apple and Google. And I'm using 3 features for each stock: the original stock price for each day, and the trade volume for each day, and then adding an average percent change from the previous day. To test these new features, I start with the original Amazon stock price and volume, then add an additional feature each time I go through the model, and find an R-squared score between the new predictions and the target holdout prices. I then compare these results with each of the previous tests and find out which features caused the R-squared to rise, and which one caused it to fall, and ended up with the final model using the Amazon price and volume and the Google price. And my initial results, I got an initial R-squared score of 0.474, and this is an all right score, but not great. Here's the graph of that, with the blue line as the target prices and the red line as the prediction prices. And in particular, pay attention to where the arrow is pointing. And these results follow a general trend of the prices, but don't capture the extremes very well. The predictions change too slowly to capture the drastic price differences, and they don't capture the maximums or minimums effectively. So to counter that, I'm using something called a scalar, which looks at the first derivative and where it is positive or the trend is increasing, and where it is negative or when it's decreasing, and multiplies the results by a scalar of either 1.1 or 0.9 respectively. And here are the results after that scalar is applied. And you can see that the graph, the predicted prices are a lot more jagged, but the jagged rises and falls follow the actual rises and falls fairly well. So it ends up with a better prediction. And the new R-squared after scaling is 0.64, which is quite a big difference. And I got a 30 to 35% increase across all the models I tested. Now a small demonstration. Takes a little while to generate the predictions, so I have one ready. And in the results, you can see that the recorded price is 3,690, and the initial predicted prices is 3,383 with an R-squared score of negative 4.554. And after scaling, the predicted price is a little bit closer at 3,417 with an R-squared score of negative 2.719. These R-squared scores are quite a bit different than what I got in the initial testing with the holdout set, since the data set is a much smaller than the holdout set, so any jaggedness in the predictions are amplified quite a bit. And some future steps I want to take. I want to diversify the features even more by finding more related stocks. And then I want to do an analysis of Amazon-related media, which includes tweets, press releases, and news articles. Then I want to gather more data. In particular, I want to use a higher resolution by the hour, the minute, rather than by the day, and over a longer time period, so I have more data for training and testing. Then I want to tune the scalar so I get the best results and performance out of it. And finally, as you can see in the demonstration, the prices, even with the scalar, don't really match the actual prices very well. So instead of predicting prices, I want to see if this model can instead predict trends. But unfortunately, there's still a lot of work that has to be done with that. Thank you for listening.